today, which was not fun. All right, so if we look at this, we see three distinct areas, and we're looking for the area of the shaded region or the area between the curves. Now, we cannot set up just one single expression for this. At least we don't know how to do that yet. Eventually we might get there where I'll tell you a quick way to do it. But what we need is to do the area. We need to find the area first, the region 1. Now, as we learned before, it's the top function minus the bottom function, but it's bound with respect to the x-axis. And I know you guys might not be able to see that from way back there. That's a -4. And it's also bound here by -2. So the first integral I'm going to set up is the red one, from -4 to -2. And then we have the top function, which is part of the parabola curve. That has to become the first piece, minus the second piece, which is the linear equation, because the linear equation is the one on the bottom. Now, if I wrote it this way, that's technically wrong. The reason why is because I need to put parentheses. I'm subtracting the entire bottom function. So that's grouped together, and then you would eventually distribute that negative. We don't need to because we're not going to clean this up or anything. But if you did not have those parentheses, technically that's wrong. So be very careful when you're doing this. So that's the area of the first part. Now we have to do the area of the second one. And you can see here, the second one, the top function switches. Now the top function is the linear one. The bottom is part of the parabola. And we're going to go from -2 to that's +1. So I just put addition here, and I'm just gonna keep writing this, or maybe I should put the addition here so you can see. But we're gonna go from -2 to 1. My top function minus whatever the bottom function is, which was the parabola. Now for this one, if you wrote it this way, that would be acceptable. However, my advice is really, if you want to, always throw the top in parentheses and the bottom. That way you're never going to make an error or accidentally put the wrong notation. Okay, and then the final piece is the area of the curve right here. That's the third section. That goes from 1 to 2. So I would have to add the integral from 1 to 2. But now my top function has changed again. It's the parabola. And then we're going to subtract the bottom function, which is the linear. And again, this one you have to have those parentheses around the bottom function. I would just suggest writing it around everything. And this, if this problem, most likely if this was a free response question, it would be a calculator one, because doing 3 integrals by hand is kind of tedious and long, and we don't want that. But if this was a calculator problem, you would have to have all of this work set up and then just show me the answer. Okay, so please make sure, even though you're allowed to use your calculator, you are showing the setup of the problem. That shows the calculus. Okay? All right. I'm sure you've all seen jokes like this. This is our quote for the day. The sine gerene and cosine gerene is equal to tangerine. Okay to laugh. Just a reminder, juniors, I have to get my roster here because, let's see, second hour we have Aaron, Sarah, McKenna, Aiden, and Sophia. You guys will be going to room 10, which is Stutzman's room, and I'll be there helping proctor that test. Other students, if I didn't call your name here in class, you will be going to the media center. And then we are going to have an asynchronous learning that day where you're just going to watch a short video, do a little bit of work. Okay? The one big thing that we talked about this before, I just want to make sure, please make sure you bring a fully charged laptop, bless you, and headphones. Now, hopefully you have the school laptop that you were given, because that has the program on it. I'm not sure, and I have to ask this question, I'm not sure what to do if a student shows up with a non-school laptop, how they access the site. So I will get that question answered, but just make sure you bring your laptop fully charged with headphones. Okay, so we are shifting our thinking today. We're still going to talk about the area between the curve, which we did was the integral of the top minus the bottom. But what happens now if I have something like this? Okay, I don't want you to write this down. Question from distant learners about the MCA. If you are learning via distance, juniors, you guys do not have to take it. It's only the students who are in Tartan that are required to take the MCA test unless they have opted out of it. If you are a junior who's learning from home, you could call the main office and ask about opting in for the MCA test, and that would be taken on a Friday at some point. I don't have a lot of information about that, so you just have to call the office and get signed up for that if you're interested. Okay, so let's look at this. We want to find the area between the curves and the horizontal line. Now, remember, horizontal lines are the y values. So when y equals c, that's the dotted line. When y equals d, that's the dotted line, and both of those are horizontal. Well, what we're looking for is when we found the area yesterday, everything was aligned nicely with the x-axis, where if you went straight down from the x-axis, that partitioned our graph, right? And we could easily find the area, I can't say easily, but we can find the area using calculus. Well, what if I try that same approach here, and I try looking at it with respect to the x-axis? Well, I've got a point here and a point here. If I divide it by one of those points, then I've got this little gap right here that's not accounted for. Or if I push that over and I divide it at this point, then I excluded all this extra stuff right here. So partitioning it amongst the x-axis is not possible for this specific case. At least it's not possible, or it's not very friendly. It would be a lot of work to find the area of this using the x-axis. But what if we shift our thinking now to the y? So what if I partition it amongst the y-axis here? You see how that's nicely cut off, and that kind of fully bounds the area that we're looking for? And same thing with c. This is nicely partitioned. And now the area isn't between the top and the bottom function, but it is from the function on the right and the function on the left. You see how that area is completely enclosed. There's no extra space. So what does that mean for our integral? How would I set this up? Well, the area is no longer between the x's, but it's between the y bounds. And my lowest bound, what do you think my lowest bound is going to be here? You have to take a guess. I'm setting up the integral. And I shift my thinking. So I'm not thinking top to bottom, but I'm thinking more left to right. Well, the lowest bound here is c. And what's the highest value of those? It's b. That's going to be my bounds that contains the area. And then, which one do you think, if we have to have the greater one come first, which one do you think would be greater in terms of how we interpret math on a graph? The right side or the left side? Right. Greater is right? Because that's positive x value, so I'm going further to the right, which is usually more positive. So what we're going to do is we're going to take the right minus the left, and then since we are now focusing on everything with respect to the y values, instead of dx, it's dy. So notice, technically, the only thing we're doing today is we're shifting our thinking. Instead of kind of being partitioned with the x-axis, now we're partitioned with the y. But because every single thing is written in terms of y, we have to evaluate in terms of y. Okay, so that's the setup today. I am going to rewrite this on the first problem we do, so you don't have to write that little description. I do want to throw out a little math disclaimer here, and this is just to set the framework for what we're doing today. We have something called the horizontal line test. A set of points in the xy plane is the graph of a function in the form of x equals. So that's key. Notice it's not y equals, it's x equals, which means y is the independent variable now, and that's what we're going to have to do. We're going to have to shift things, so now it's written as x equals. And you'll see that in the first example here. And that's going to be true if and only if every horizontal line intersects the graph at most at one point. So do you see how this horizontal line B hits the blue graph only at one point? And same thing with the green. It hits only at one point. And then the horizontal line C also has that same condition. Kind of like the vertical line test when we talk about functions normally. Well, if that's all true, they're telling us that you can take the area is the integral from c to d of f of y minus v of y. A better way to write that is what we did up above. The right minus the left, and just notice everything is written in terms of y. Okay, so that's kind of just setting the stage for the mathematical side of what we're doing today. This is what I'd like you to write down. So we're still in section 8.1, which is finding the area between curves. But our focus now is everything. I can't say everything because they could throw an x value at us, but almost everything we do today is focused on the y values. So the directions don't change. They're just going to say find the area between the curve. What you have to know is that with the given information, you have to determine, should I use the x values or should I use the y values, and which one is going to produce the easiest or most accurate results. Sometimes you can do it both the x and the y-axis. That will happen. And I'll kind of show you a case when that could happen. So what I would do is I would draw a very rough sketch of this graph. It doesn't have to be perfect. And then just kind of lightly shade in that red area. As you're drawing that, let me show you, if we tried to take the approach that we did yesterday, let me show you why that wouldn't work. So if I try to do this, and again, don't write this blue part, I'm going to erase it, but what if I try to partition it with respect to the x-axis? So the lowest x we have would be here at 0. And the highest x that we hit is right here at 4. But notice the area between the top function and the bottom function doesn't cover all of the graph. We have this extra space that would be counted for. So it's not perfectly easy or quick to partition amongst the x-axis. So today, we're shifting our thinking. Now, what if I go with the highest y value? So here's my highest y value. And then what if I go with the lowest y value for where the graph is shaded? Now where are those at? That's at y equals 0. And it's at up to, this is spot y equals 2. Now notice, instead of calling it a top and bottom function, we have the function that is the most right between 0 and 2. And then I have the function that is the most or the furthest left between 0 and 2. And notice, this area, there's no extra spacing. It fits this perfectly, which means if I find the integral from 0 to 2 of the right to left function, then we're in a really good spot. Now, I'm going to treat this problem as if we didn't know the graph existed. Okay? Because that sometimes we won't give you a graph. So what's the first thing that we kind of need to do? Since everything is now referred to the horizontal lines, so we're partitioning it amongst the y-axis here. We have a top and a bottom split. We need to rewrite each equation in terms of y. So I'm going to take both of those equations and just do some really quick algebra. Doesn't matter which one. Let's take the linear. And really, I'm just solving for x. So if I add 2 over to the other side, I get y plus 2. And then I just like to put the x out front. So there's how that equation will be rewritten. And then the other equation, we just have to solve for x. So we'll square both sides. So I'll get a y squared. And then personally, I just like to have the x on this side. I want to throw a real quick note out there. Don't write this, but what if I had this equation right here? What if it was written as x plus y equals negative 2? Sometimes that just scares kids when x and y are on the same side. If that's the case, we're still doing the same algebra. You want to write it in terms of x. So I would just move the y over, and I'd get the same answer. Okay. Did I write that on? That would be a negative, because I subtract the x. But just so you're aware, if x and y are on the same side, you still need to just solve for x. And I believe that comes up later on today. Okay. The second thing we're going to do is set up the integral that represents the area. This is the calculus side. So far, nothing we've done is calculus. What is the area? Well, since we're changing our thinking, we are going from the lowest y value to the highest y value. Kind of looking at that vertical line being moved up and down. Well, the lowest y value is at y equals 0. And the highest y value is y equals 2. And since area is the most right function minus the left function, instead of top to bottom, because we're now shifting our thinking, it's the furthest right is considered the higher value or the greater value. So which function is the furthest right? It's the linear equation. However, I need to have the equation written not in terms of y, but in terms of x. So we're going to take that new algebraic expression, and that will be the right farthest function. And then what's the left farthest function? That's the one that originally had the square root, but we had to rewrite it in terms of y. And then hopefully this really makes sense. What's going to go right here? dy. Right? It can't be dx because we're making reference to everything in terms of y. Which hopefully gives more evidence as to why we had to do this first step. We had to rewrite things so the equations were written in terms of y. Now, we are going to do this one by hand. And the fact that it's y doesn't mean any different to us, right? We're still going to take the antiderivative. We're going to still evaluate. I will just let you know that this is my personal choice. If I'm going to evaluate, I just like to have this minus y squared written first. So I just rewrote the order. You do not have to do that step. But now, go ahead and let's solve. Take the antiderivative of each piece, and then evaluate from 2 to 0. So I'll give you a minute or two to work on that. Evaluating this. So we're going to take the antiderivatives by adding 1. If I add 1 to the squared, I get a 3, so y to the third. But I have to put a 1/3 out front, and that negative is just going to follow down. If it's just y, that becomes y squared, so I have 1/2 y squared plus 2y. And then notation-wise, we didn't do anything with the bounds, we took a straight line and evaluate. And then we're going to go ahead and test from the upper bound minus the lower bound. So I'll plug 2 in first. Now, to save some time, you have to be really careful with this. If I'm plugging in 0 to all of the y values, it's going to make every output 0. So I don't have to show all that work if I know the answer is 0. However, if I had a sine function or a cosine function or e to the x or ln, then you have to be very careful with that 0. A 0 doesn't always mean every single output will be 0. So just be very careful with that. And now it's just algebra. So this will become 8 times negative 1/3 is negative 8/3. 2 squared is 4. Half of 4 is 2. However, I'm going to call that 6/3. So 2 is the same as 6/3 because then I can combine fractions easier. Plus 2 times 2 is 4. But a better way to think of 4 is 12/3 now. And that just allows me to set things up to easily add and subtract fractions. So now I got negative 8 plus 6 is negative 2. Negative 2 plus 12 is positive 10/3. So let's just look at this problem and see what's technically new. Once you set up the integral, nothing changes. However, well, let's say the only new part is really changing our view. So instead of looking at it in terms of the x-axis, we're looking at it now by partitioning the y values, which means we had to change all the equations so they're written in terms of y. And then we set up the integral from right to left this time. But how do I do this in my calculator? Well, grab your calculator right now, and I'll show you. Nothing changes. You do the same thing you would, except for we only have the x variable. We don't have a y variable. So all you're going to do is just type this in, but instead of the y's, just put x's. And see if you get the same answer we did down here. So go ahead and test that quick. I'll show you mine once I get everything entered. So this is what I got. I got 3.3 repeating. But what if they want me to answer as a fraction? In that case, take your answer. So go math, option 1. Turn it back into a fraction, and there it is, 10/3. Okay, so even though it says y's in our handwritten work, we would have to enter them as x's for our calculator. Just be aware of that. All right. So this is where things get a little more challenging. And I don't want you to write this problem. Okay? we're not going to waste a ton of time. I'm really going to treat this as if we had more time in class, because of hybrid learning and the amount of time we have, there's certain things that we just aren't going to review as often as we would if we were in class. And one of them might be something like this, is I have two functions and the x-axis. So I have to create a graph. Now the question is, do you really remember what the graphs of square roots look like? And do you know what effect it has on the graph? And I'll say, it's my experience that most students aren't super familiar with that. So what if I took each one of these and I solved for y? All right, I shouldn't say I solved for y. I wrote it in terms of y. So what if I squared? And then I bring everything over, and I divide by -1 or -4. So the first one I just solved for y. So I'm sorry, I wrote it in terms of y. Now, do you connect with this? And this is the part where if we had more time, we'd spend a lot more time doing this. Here's the way I look at it. If x equals y squared, well, if it was flipped around, if it was x squared, it's a parabola opening upward. Well, when I switch x and y, it's just the inverse, which means my parabola now is shifted sideways. So it's a parabola that's negative. So right away, the 1/4 means it's going to open smaller. So it won't be as narrow as a normal one, or it'll be wider than the normal one. And then I'm going to shift 1 unit to the left. And that vertex would lie right there. So I'm not sure how much you guys remember doing all that. Don't worry, because I have a nice little out in case you don't. And then I'd have to do the same work for the second equation. So I'd square both sides. And then I would subtract 4. And then I'd have to divide by -1. So what does this graph look like? Well, -y squared. The negative is going to take the parabola and flip it so it opens the opposite way. And then, because it's y, it's now opening the other direction. And then we're going to move it 4 units to the right. So this graph would look like this, and at some point they're going to cross. And I have to find the area between those curves and the x-axis. Now, without a calculator, how do I know where these graphs are going to intersect? This is something we do expect you guys to be comfortable with. It doesn't matter which form I take. I can take these two and set them equal, or I can take these two and set them equal. But if I have two equations and I want to find out where they intersect, you set them equal to each other. So I'll take the blue one and set it equal to the red one. And then I have to use my algebra to solve. So in this case, if I add a positive y over to this side, and notice that's I'm going to call this a positive 4y. So when I add them, I get 3/4 y squared minus 1 equals 4. That's what reduced that side out. And then here, if I add 1 over to this side, I get 3/4 y squared equals 5. And then I could times this side by 4/3, so I'll get 20/3. And at some point here, it doesn't get super friendly. Then I'll take the square root, and I get a plus minus square root 20/3. So what does that tell me? That tells me that even though my graph, which is very poorly drawn, has a y value of square root of 20/3 in the positive side, and the negative side. So now I can still set up all this partition, this area, because of the algebra that I did. So look at the area. The area is going to go from the y-axis, which is 0, to the upper bound of y, which we just found as the square root of 20/3. And then it's the most right function minus the most left. So then I just have to look and see, well, what was the most right? It was the red one. And then we're going to subtract the left one, which was the blue equation. And then I would say, we grab our calculator, and to be honest, I don't even care right now the answer on this. What I wanted to show you was, right now you're probably thinking, Strub, come on, what in the world are you talking about? Right? You're expecting me to remember all of this from Algebra 1, Algebra 2, Pre-Calc even, and then I have to create a graph? And I agree. We don't have the time for you guys to be super comfortable with this. So here's what I want you to do. If you come across a problem and you don't know the graph, Desmos is one of your most friendly resources for graphing. So if you go to Desmos and you just get a graphing calculator, and let's say that I want to graph either this one up here, which, yeah, you could do this in your calculator, but what if I have an equation that looks like this in terms of y? So negative 1/4 y squared minus 1. Oops, I don't want the y. Bottom, I want the y. So look at that. There's my parabola, opening sideways, going to the left at negative 1. Okay? And then, I forgot what the blue, or the red one was. Negative y squared plus 4 equals x. I guess it's plus 4. And there you go. I would
Now, this is really for just homework, right? And then the nice thing about Desmos, notice how it gives you those answers right away. You know the intersection point, so I didn't have to do all of this work to get that answer. It automatically finds the intersection point really quickly. So that's just something I want to show you is Desmos is there if you do not have the ability to create the graph on your own. Okay. I want you guys to, we're going to do this as a calculator problem. And our directions are find the area between the curves. However, they use function notation, which can be kind of confusing. And they give us a domain. Or really, this is kind of a range because it's the y values. But I want you to draw a really rough sketch of this. And we're going to set this up, and then we'll use our calculator to find the answer. This would definitely be one of the times where if you weren't given this graph, I don't expect you to know what the graph of cosine squared y is or what the graph of sine squared y is. Even though you might know, you might have an idea, it's really just kind of the inverses of the inverses of cosine squared x and cosine squared or sine squared x. But use Desmos, it'll give the graph. The important part right here is they give us a condition. We have to look at the y values, notice y values here, between negative pi over 4 and pi over 4. Well, that automatically tells me my bounds. Right? So if I'm looking at this, this is the equation of y equals pi over 4. And down here, the other intersection point is the equation of negative y equals negative pi over 4. And you can see that the area between the curves are nicely bounded from top to bottom. And what we need to do is find the area between the two curves. Now the question is, what if they give you this graph? How do you know which one is your right function and which one is your left function? Okay. If they give you the graph, you still might have to determine which one is which. Here's what I would do. Let's test the point. This is x and this is y. What if I plug in y equals 0? Well, the cosine of 0 is 1. 1 squared is 1. So when y is 0, x is not 0. So this graph right here cannot be the cosine 1, which means it has to be the sine 1. And what if I test that? If I plug 0 in here, 0, the sine of 0 is 0. 0 squared is 0. So that's proof that this graph right here is what they're going to call g of y. So I used the point to test if I wasn't confident already. And then likewise, if you want to confirm it, if you plug in y equals 0, your output is 1. So that proves that this green one is the graph of f of y. Okay. So what's the only work you would absolutely have to show for this problem? Setting up the integral. Why don't you do that right now? Set up the integral, and if you're comfortable, go ahead and solve it using your calculator.
So that's what it should look like. Your lowest bound is the y value at negative pi over 4. Your highest bound, your upper bound, is the positive y over 4. And then you take your right bound minus your left bound. The only thing you might have to be careful with is when you enter the squared into your calculator. Because when you type in cosine, it automatically gives you the parentheses. So what you have to remember is when I write cosine, remember that squared can come at the back side, and you might even want to put extra parentheses around that, depending on what type of calculator you have. So this is how you have to write it because of the way our calculator requires you to type it in. So go ahead and give that a shot. See what you get. And since we're dealing with trig functions, you do have to be in radian mode. All right. Joel informed me that if you use the y variable, so I tried it with this one. My old calculator years ago would not let me do that. So I'm going to try it with the y. If you put the x, you get the same answer. But I just used the alpha 1, and that's y. And I'm curious if we get the same answer, which I think we will, because I trust Joel's judgment. And you're right, we got 1. So I guess I learned something today, is that if you use the y variable, that works. You can also use the x. But at the end of it, you should have got 1. And just take a little note as to how I typed this in. My calculator, I didn't have to put the extra parentheses around the cosine, but some of yours you might have to. So today, I am going to be doing, the students in hybrid, when you come back this afternoon, we're actually going to be doing a full free response question. So when you show up, I'll give you the actual printout of it. You'll get 15 minutes to do the question, and then we're going to grade it. And it's not worth points, but we're going to grade it as to just see how well you would do. And we're going to start doing this at least once, maybe not twice in the afternoon a week, just so you guys get more practice. Those of you who are on Zoom, if you would like to have the same opportunity, I'm going to just have it up here on the board, and you'll be able to just work through it, give yourself 15 minutes, and then correct it. So what that means is you just have to keep mind of our schedule here. We are back in the afternoon at 12:55. So students who are interested, you can attend my office hour link and then just show up, and I'll have that link up there. I cannot post because the free response question we're doing, it's a secure question. I cannot post a video of it. I cannot post my answers. You guys are allowed to do the work on your sheet, but I actually have to collect this before you leave. So it's nothing you're going to take home with you, but it's just a learning experience that it's a really good opportunity to show and do that. So I hope those of you that are going to attend in the afternoon on Zoom, you're ready to go right away at 12:55. Tonight's homework, though, is 7 questions in the textbook.
If there's a graph provided, I want you to be very clear on this, because I want you to, like, let's say that there's a graph provided like this. If the graph is provided, you can read the graph as long as you're confident in the intersection points. And then what would you do? You would set up the integral like this, and then if it says to not use your calculator, you would need to do the work by hand. If it says to use your calculator, then all you would do is write this and tell me the answer. Okay? If there is not a graph provided, kind of like this one, then you should draw a very rough sketch of a graph. Like we had said, if you need, Desmos is there to help you out. But almost everything today is with respect to the y-axis.